Alright, so we are looking into the idea of formula for alkenes, sorry. And so this is the table. This is the same table that we did for alkenes as well. And we're going to be doing the similar things for alkenes and even for alcohols later on. Okay, so let's start with something that we call ethene. And you don't have a methane here, like as in methane for alkanes and methane for alkenes. And the reason, because it's, if you notice that methane is just a single carbon element, it's just a single carbon molecule. But if you talk about methane, methane cannot exist because for alkenes to exist, there should be two carbon molecules. And why is that? Because you need a double bond in the middle. So if you have just one single carbon molecule, you cannot have a double bond because hydrogens can only make one bond, right? So that's why we have something that we call ethene. Now, ethene, if we were to write the molecular formula for this, this would be pretty easier if we start making it from the full structure formula. So let's draw the full structure formula first. So this is the full structure formula for ethene. Okay, this is the full structure formula for ethene. And if I were to see the molecular formula, so you have two carbons, so this is C2 and 4 hydrogens. So this is C2H4. This is C2H4. And if I were to talk about the structural formula, now this is where it gets interesting, because what do? We break it from the middle and we have a CH2 here. So this is a CH2 and this is a CH2, right? And in the middle, you have a double bond. So this is CH2 double bonded to a CH2. And that is what is the structural formula for this ethene molecule. Okay, so this is CH2 double bonded to a CH2. Make sense? Okay, let's look at the other molecule. Just a second. Okay, let's look at propene. Okay, let's draw the structure first. So propene, now that is a 3 carbon molecule, and you can have a double bond here. So this is 1, 2, 3, 4. This is 1, 2, 3, and 4, and this is 1, 2, and 3, and 4. Okay, so now how does this work? So I think I'm missing an H in the middle. Yeah, so you're gonna have an H here as well, and we can draw this one, this H molecule, we can draw it here. Okay, so now if I were to ask you the molecular formula for this, it's going to be C3 because of 3 carbons, and you've got 1, 2, 3, 4, 5, 6 hydrogens. So this is C3H6. So the molecular formula for this is C3H6. And if I were to ask the structural formula, so what you can do now you don't really need to break it. You can easily understand just by looking at it. Or even if you want to break it, let's just break it. So this is a CH2 first. So this is a CH2. Let me write it here. This is a CH2, and that is double bonded to what? To a CH. To a CH. Okay. And now that CH is single bonded to a CH3. Right? So you have a CH2 here, you have a CH in the middle, and then you have a CH3 at the end. And the CH2 at the start is double bonded to a CH in the middle. So this is your what? This is your structural formula, not full structural formula. This is your structural formula. Okay. Okay. Right. Now let's look at butene. Now butene, if I were to draw the full structural formula for butene, so let me just take this down. Yeah. Okay. So you can have a double bond at any place you like. So have a double bond here, like this, and this is 1, 2, 3, 4, 4 bonds, and this is 1, 2, 3, and this is 4, and this is 1, 2, 3, and this is 4. Okay, and yeah, this is correct. Okay, so now if we were to figure out the molecular formula, that's simple. We have got 4 carbons, so this is C4, and we've got 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. Okay, and even if you want to check this out, you can just quickly plug this value of 4 in the formula. So the formula is CnH2n. So this is C, the value of it is 4, H4. So this is C4H8. So whenever you kind of get stuck on the fact that on the bonding or anything, like have you draw correct amount of hydrogens or not, you can just quickly place the value of n in the formula and figure out the right molecular formula. Okay, so this is C4H8, that is the molecular formula. And if I were to talk about now the structural formula, now you can break it from here. So this is CH2, which is double bonded to a CH. Okay, then that CH is single bonded to a CH2, and that CH2 is again single bonded to a CH3. And you don't need to show the single bonds. I might have showed in the first one, you don't need to show it. Okay, so this is the molecular formula. This is the molecular formula. No, this is the structural formula for this molecule. All right.